All right, 8th graders, here is your test review for Chapter 10. I'm trying really hard to focus on the things that are going to be on the test. I'll try and give you a little bit of background information and things, but I basically took stuff that looks exactly like what you're going to see on the test to help you prepare for that, because I know this is a really big chapter. Remember, you can use your notes on this test. All right, so what do you need to know about quadratic functions? Well, let's just do a little backup information. A quadratic function is a function or a polynomial that has the highest degree of 2. So it's something x squared plus something x plus something, if we had it in like a standard form, right? So it's never going to say like x to the third power or x to the fourth power. It's always going to say x to the second power. Again, it's not going to say like mx plus b, because that would be linear, as we learned earlier in the year. When they're graphed, they look like an upward or a downward parabola. Remember, this is an upward parabola and this is a downward parabola. We know that it's upward if the a value is positive, and we'll talk about a values. So a value is positive, a value is negative, and that is how we know if it's upward facing or downward facing. The solutions are where this parabola runs into the x-axis. So we would say if this were the x-axis, the blue going this way, is the x-axis, these points here, those are what we would call our zeros or our roots of the function. Excuse me. So if I'm solving the function, I am trying to find out what these little yellow spots are. Now we could have 2 roots or zeros, we could have 1 root or 0, or we could have none at all. I'm going to go through a lot of examples where we have 1 or 2. I'm not going to use any examples where we have 0, because on your test there are also no examples where there are no roots or zeros. So that is like the main thing that we're trying to do when we do this. But there are a lot of other things that we can find. We can find the axis of symmetry, the y-intercept, the vertex, the domain, the range, and we're going to talk about how we find all of those things. Going back up to that green section, also, there are lots of ways that we can find these zeros here that we have. One is that we can find it by looking at a graph. Right there, you can see it on the graph. We can use factoring, where we're saying what adds to this and multiplies to that, to find 2 things that multiply out. We can complete the square. Now, this one we actually didn't do in this chapter. We're going to do it as an add-on to this chapter after the test, and it won't be tested. And then we could also use the quadratic formula, which we are going to talk about. Okay, so here are all these different things that we can find when we look at a graph of a parabola. We can find the zeros, the axis of symmetry, if it's a min or a max, what the vertex, the domain, the range. So let's talk about all of these parts. The zeros, as mentioned on the page before, is the spot where the parabola runs into the x-axis. Now, I will not give you anything that's going to be a crazy answer, so you're going to see that it's going to be pretty straightforward. Like, this is obviously on 1 here, and this one is obviously on 5. It's not going to be like 5.5. So my zeros are 1 and 5. Now, they should probably be written as an coordinate, so I'm going to say 1, 0, 5, 0. That's the best way to write them. However, if you wrote 1, 5, I would not do this, but if you do 1, 5, I'll know what you mean, because I know where the zeros are. The axis of symmetry. Well, think about symmetry from when you were little. Like, symmetry is where you could like fold the shape, right? So if I folded this parabola, I could fold it right here, and the left side and the right side would look exactly the same, right? So when I look at that, I see that my axis of symmetry is on the number 3. So x equals 3 at my axis of symmetry. You will be given this x equals. All you need to do is fill in the number that x equals on that line of symmetry. Okay, so if I were riding this like a roller coaster, I go up, 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 stop, down. The maximum point is right here. So we're saying the vertex, which is this spot, either the top or the bottom, the minimum or the maximum, is a maximum. Why? Because it's the highest spot on there. Okay, so if we're looking at something that's the highest spot, it's the maximum. If we're looking at something that's facing the opposite way, it's going to be a minimum. So I'm going to circle that. On your test, it tells you to circle max or min. Okay, what does y equal at that point? Well, if I look over here at the y equals 4 at that spot. So y equals 4. My vertex. Well, I said my vertex is this point right here where it changes direction. Okay, so this point, I'm just going to list it's over 1, 2, 3 and up 1, 2, 3, 4. So this point is 3, 4. Okay. The domain for every single one of these is going to be all reals. So every single time you see this, go ahead and put all reals, but let me explain why. As you see that this parabola is slightly going to the left, more and more and more and more and more right. I mean, maybe I'm going a little too far up, but it continues to go to the left as it goes down. And this is continuing to go to the right as it goes down. It doesn't go straight down, right? It's going at an angle. So if you went and you continued this line forever, it would never stop going to the left or to the right. So that means every single number on the x value, which is our domains, would be included. But if I tried to look at my y values, that's the range, I noticed that there is not a single thing up in this area right here, right? It's all at 4 or below. So we would write that as y is less than or equal to 4. Okay, so that's saying 4 is the very top and everything else is below it. All right, moving on. Here's another example. I chose to do a second one because there are 2 like this on your test. One will open upward, one will open downward. So one will have a min, one will have a max. If we're looking at the zeros, interesting. I probably should have chosen something a little bit different. This looks like it's almost the exact opposite of my first one, but I still have the same zeros, right? Wasn't it 1 and 5 on my other one? I think so. So 1, 0, and 5, 0. Again, 1 and 5 would be acceptable answers. The axis is symmetry. Well, look at that. Write down the number 3 again. So it's 3. It is this time going down, 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 stop, up, 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 up. So this is the very lowest point. It is a minimum. And where is that minimum? This time it's at -4. Okay, my vertex is going to be the spot at the very lowest point, and that is 3, -4. My domain, again, all real numbers because it's going to keep going as it goes up. Okay, and the range, there is nothing below -4, so we're going to say y is greater than or equal to -4. All right. This one doesn't have a graph, but we're asked a lot of similar information. Like we still have our zeros on here. We still have the vertex. We have upward or downward instead of min and max. But a lot of similar information, but different ways of finding it. So let's go ahead and use what we know. First of all, this is in standard form right here. Okay, so standard form looks like this. This is my standard form. If you forget what things are A, B, and C, this is on your test. Right here, it's on your test. So A is whatever comes in front of the x squared, and B is whatever comes in front of the x, and C is the constant at the end. So notice there is nothing here. Does that mean there's a 0 there? No, because that would make this term disappear. That means that there is a 1 there. So we're going to call A 1. And B in that spot is a 4. So we're going to put a 4 there. And C is a 3. Now, if there are any negative numbers or minuses here, we would put negatives in these spots here. Okay, remember to always use the sign in front. Now, we look at the A term. If the A term is positive, it's an upward. If the A term is negative, it's a downward. And this starts with a positive value, so it is an upward facing parabola. All right, moving down here to the axis of symmetry. This axis of symmetry also gives us a lot of clues. It gives us an exact formula. We need to figure this out. Well, what is B? What is A? You just told me right here. Here's B and here's A. So I'm going to plug these numbers into the formula. Negative B would be -4 over 2 times A, 2 times 1A. Okay, so negative 4 divided by 2 times 1 is 2. Negative 4 divided by 2 is negative 2. Okay, so what is my axis of symmetry? It is x equals negative 2. So if x equals negative 2 at my axis of symmetry, my vertex, the x for my vertex, is going to be negative 2. Now, you might get confused when you look at vertex and it says h and k. Remember, h and k are used when we take our vertex and we put it in vertex form. So that's actually there to help you when you go down here to transfer it into vertex form. So we need to think about our vertex is a xy coordinate that will translate into an h and a k. They're the same. Basically, think of them as the same thing. We had to use different values, though. Okay, so if I know that my x is negative 2, I need to figure out my y. The way that I'm going to figure out my y is I'm going to take it and I'm going to enter it into the formula up above. So I'm going to take my negative 2 and I'm going to put it every time I see an x. Okay, so negative 2 squared. Remember, your calculator will lie to you. If you just write negative 2 squared, it's going to tell you negative 4. That's not correct because negative 2 times negative 2 is positive 4. If you want to use your calculator to do this and you have a negative value that you're doing an exponent to, you need to put the value in parentheses so it knows the negative belongs with it. It's kind of tricky. I like to just do these in my head. Negative 2 times negative 2 is positive 4. Okay, and then I've got this one. 4 times negative 2 is negative 8. So minus 8 and plus 3. So I'm going to take these three values and I'm just going to put them together. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. Okay, it's two different colors, but that's okay. So I've got negative 2, negative 1, and that is my vertex. So if my vertex is my h and my k, that means h is negative 2 and k is 1. Okay, so down here, I'm going to enter those in. Now, the value for a was just 1, so you could choose to put a 1 there, or you could leave it off. Because remember, when you multiply by 1, it doesn't actually do anything. And so it's okay if you don't put it there. It's okay if you put it there. I don't care. Either way, it's fine. So then we're going to do x. So remember, this x is different up here. We don't want to put our actual vertex in this spot. We want that to be reserved for a different x value. So we're going to use h and we're going to use k for these numbers. So I'm going to go minus negative 2 because my h is negative 2. So if I said minus negative 2, we want to clean that up. We don't want it to say minus negative 2. So we're going to say a minus minus is the same as a plus. So we're going to say plus 2. Squared, and then here it's a negative 1. I almost messed up. See, negative 1. Okay, so if it's a negative 1, I could, instead of saying plus negative 1, I'm just going to say minus 1. Okay, and that's my vertex form. Okay, so now when you get to the bottom here, we do not need to use things that we've already learned up above to get this factored form. We only need to use this original equation, and it's kind of hard for me to see it, so I'm going to rewrite it down here. It says x squared plus 4x plus 3. Okay, so we need to find out what multiplies to be 3 and what adds to be 4. So I'm going to go over here. I'm going to list out the things that multiply to be 3. Well, 3 is prime, so just 1 and 3. And luckily, 1 plus 3 equals 4, so it's going to work out to be 1 and 3. So what I'm going to do is I'm going to make two values. I'm going to do x plus 1 and x plus 3. Now notice these ones say minus in them. You don't have to worry about that. We're going to find our two numbers here, and if they're positive, we're going to add them. If they're negative, we're going to subtract them. Okay, and so this is my factored form. Well, how do I find my zeros from my factored form? I say, well, if this were to be 0, what would x have to be? So if x plus 1 equals 0, then x has to be negative 1. So one of my zeros is negative 1, 0. Okay, and the second one, well, what would x have to be here? If x plus 3 equals 0, then x would have to be negative 3. And you're going to find these are always their opposite. Okay? All right, this one's a little bit different. I'm starting with the vertex form. Oh, ignore this little thing here. Okay, so vertex form. Remember, vertex form is where this is my h and this is my k. But in the formula, it says x minus h squared plus k. And so the h is only the number that's after the minus. So we're going to take whatever is here, and we're going to do the opposite of it to find my vertex. So the opposite of plus 3 is negative 3. The reason we're doing that is because this formula has a minus in it, not a plus. So we have to use the opposite of what we see. So this really was saying minus minus 3. Somebody changed it to a plus 3. So if it said minus 3, the h would be a minus 3. Okay, and then the k is exactly how you see it, negative 1. If I want to write this in standard form, what I'm going to do is I'm going to take this original, let me try and clean this up. Sorry, I write all over things. Okay, so I'm going to take this original thing here, and I'm going to actually multiply it out. So this is saying x plus 3 squared. So I'm going to say x plus 3 times x plus 3. And then I'm going to ignore this piece, and I'm going to put it on at the end. So I've got x times x is x squared, and x times 3 is 3x, and 3 times x is 3x, and 3 times 3 is 9. Okay, so then I'm going to put my like terms together, and I'm going to add this minus 1 at the end, put those like terms together. So now I have x squared, I'll erase this in a second here, x squared plus 6x, and then plus 8. That's my standard form. So I am not going to be a super stickler on if you have this, but that's the correct way to write it. And then x squared plus 6x plus 8. All right. So you saw how I got it. I just did the actual multiplication within there. So I basically did the math that I could to try and change the problem, and it ended up being in standard form. Okay, now I'm going to use a couple things that I know to find my vertex. Or sorry, I already have my vertex. So, sorry, I'm trying to change pen and talk at the same time. It doesn't work well for me. Okay, so I know my vertex. I'm going to put my vertex in this highlighted spot here. I highlighted that to kind of help remind you that the vertex is going to be in the center. Just like in a parabola, we want the vertex to be centered because it's the bottom point or the top point in your parabola. Okay, so now I'm going to go, I could do two things. I could use, because this is an x squared, I could use the plus 1 plus 3 plus 5 method. We don't need to go as far as plus 5, which means I go from my vertex, I'm going to go over 1 and up 1. Over 1 and up 1 in the opposite way. Then I'm going to go over another 1, but this time I'm going to go up 3. So over 1, up 1, 2, 3. Over 1, up 1, 2, 3. Okay, and connect those lines. I would say if you can remember the 1, 3, 5 rule, that's the fastest, easiest way to do this. Okay, but you could also just say, okay, I want to go backwards 1 and forwards 1. So backwards 1 would be -4, forwards 1 would be -2. Then backwards 1, -5, and forwards 1, -1. Okay, so all I did was I went 1 this way, right? 1 the other way. And then I can take those numbers and I can plug them in. So I can go ahead and put -2 in for x. I'm going to say -2. Oops, let me change color. I'm going to do -2 squared plus 6 times -2 plus 8. So -2 times -2 is 4, plus 6 times -2 is -12 minus 8. So I've got -8 plus 8, and I have 0. Okay, so we know that this going this way and going this way from the vertex of a parabola are going to be exact mirror images. They're going to look exactly the same. So I can, if I trust myself, I can go ahead and put a 0 there as well. Okay, and then when I go ahead and plug in the negative 1, I'd say negative 1 squared plus 6 times negative 1 plus 8. Okay, I'm doing the math. Negative 1 times negative 1 is 1. 6 times negative 1 is negative 6 plus 8. Okay, so now I've got 1. Negative 6 is negative 5. Negative 5 plus 8 is positive 3. Okay, on the opposite side, I'm also going to have positive 3. Now, if you look here, I got the exact same things, right? I got 0. So at negative 2, I got 0. At negative 1, I got positive 3. And same. Okay, so the easy way to do this would be to use the plus 1, plus 3, plus 5 rule. Remember, that only works perfectly when it starts out as an x squared. If I have an a value, for example, if my a value was 2x squared plus 6x plus 8, let's just say. I'm just making things up. Okay, then I would take my 2 and I would apply it to the 1, 3, 5 rule. And I'd say, okay, I've got to multiply this by 2. So instead of going over 2, or sorry, over 1, then up 1, up 3, up 5, I'm going to go up 2, up 6, up 10. Okay, so that's how that would work. That is for all of you going into honors geometry next year, because everyone else will have lots of repeat and not need to go that far. Okay, the last thing. Ooh, this turned out really fuzzy. That's okay. I'll sing it for you. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You will need to memorize that in order to get 3 points on this next test. So make sure to tune in. I already connected that to our Google Classroom. So listen until you've got it mastered. And then on the actual test, I will have it for you when you need to use it. Okay, so it will look like this, only hopefully a little less fuzzy. So we need to know our A, B, and C. So on this first one, A equals 1 and B equals negative 8. Careful, you got to make sure you include the negative. And C equals negative 9. So what I'm going to do is I'm going to just plug these in. X is equal to negative B. Well, B is negative 8, so negative 8 is just 8, plus or minus the square root of b squared minus 4 times a times c, that's a negative, all over 2 times a. Okay, now all I'm going to do is I'm going to take this piece by piece and I'm going to make it simpler. Okay, so first I'm going to go do this ugly part that's underneath here. I'm going to say negative 8 times negative 8 is a positive 64. I'll write it over here, positive 64. And then negative 4 times 1 is still negative 4, and negative 4 times negative 9 is positive 36. So on your test, expect that I give you one that turns out to be a beautiful whole number answer where when you take the square root of it, it works out nicely. Okay, so this one ends up being 100. Oh, what a beautiful perfect square. Okay, it won't always turn out that way, but as we're just starting to do this, we're going to make them pretty. So I've got a square root of 100, which is 10. So this whole thing can trade to be 10. And this thing, 2 times 1 is just 2. So that's easy. So now I'm down to just these 3 numbers. Well, this confuses a lot of people. What the heck is plus or minus? It means I'm doing the problem twice. Once I'm going to do it with plus, and once I'm going to do it with minus. So once I'm down to these 3 numbers, I'm going to rewrite this. I'm going to write 8 plus 10 divided by 2 and 8 minus 10 divided by 2. And those 2 answers are going to be my 2 zeros. So I'm going to go ahead and do this. 8 plus 10 is 18, divided by 2 is 9. So one of my zeros is 9, and I can write that just as 9, or I can say 9, 0. Okay, and then 8 minus 10 is negative 2. Negative 2 divided by 2 is negative 1. And again, I could write it as negative 1, 0, but I am fine with you writing this as 9 and negative 1 as your answers. That would give you 100% still. Okay, the second one. My A equals 2, my B equals 2, and my C equals negative 12. Here we go. X is equal to negative B plus or minus the square root of b squared minus 4 times a times c, it says negative 12, all over 2a. All right, so again, I'm just going to simplify this as best I can. I'm going to say 2 times 2 is 4. I'm just going to do the math part down here. So 2 times 2 is 4. Negative 4 times 2 is negative 8. Negative 8 times negative 12 is positive 96. Oh, I didn't mean for this to happen, but I got it 100 again. So I've got a square root of 100. Awesome, which is 10. Okay, so this whole thing, again, makes 10. I wish I had a better variety here. And then I'm going to take 2 times 2, which gives me 4. So let's rewrite these problems. I've got negative 2 plus 10 divided by 4. Okay, and negative 2 minus 10 divided by 4. So negative 2 minus 10 divided by 4. And in the first one, negative 2 plus 10 is positive 8 divided by 4 is 2. And the second one, negative 2 minus 10 is negative 12. Negative 12 divided by 4 is negative 3. Okay, so those are my 2 zeros, also written as 2, 0, or negative 3, 0. All right, thanks for sticking with me till the end. Have a great test.